So remember, we can always evaluate an expression, say x, well, let's say 3x plus 8 for some given value of x. If x equals 9, then what would this have to be? And we did that by using the substitution algorithm, which is just to plug in an equivalent value. So if in this parenthesis used to be an x, well, since x equals 9, then it's safe for me to put a 9 in because x and 9 are the same thing because they're equal. And then 3 times 9 is 27 plus 8, and that equals 35. So this is evaluate an expression. And it's a super important part of evaluating equations, right? Or being able to work with equations to solve problems in the real world. We're going to use this same process to check for solutions to equations. So let's talk a little bit about what it means to be a solution to an equation. Suppose I have 2x plus 9 equals 14. So this is different than an expression because I have that equal sign. This is now an equation. But I want to know, so this is like a problem, right? I've created a problem to solve, and I want to know what x value would be a solution, because not everything is going to make both sides of this equation true. But before we learn methods for solving equations like this and much more difficult, we want to first just get really solid on our understanding of what it means to be a solution. So I want to check to see in this equation if x equals 3 is a solution. So I'm just going to check. That means I'm going to do exactly what I did before, only now I'm going to put my test value into the equation, but I'm still putting it exactly into the same place I did when I was dealing with expressions. So inside of this yellow paren used to be an x, but we know that x equals 3, that's the test, and we don't really know if that's true or not yet. So I'm going to put a question mark because I can't say that both sides are equal until I've tested it. So let's see. 2 times 3 is 6. Plus 9 equals 14, and 9 plus 6 equals 15. 15 equals 14. Is that true? That is definitely not true. That means we can say definitively 3 is not a solution to the equation. Meaning it doesn't make that true. So I haven't solved a problem because I haven't come to a truth in the end, so I still have a problem. In fact, the solution to this equation isn't even an integer. It ends up, it's 2.5. Now, you would have had, by guessing, you would have had to guess for 1,000 years before, okay, maybe not 1,000 years, but you would have guessed more than once, and it would have been very annoying at some point. So you're going to be grateful later when we learn how to actually solve equations like this rather than have to guess and check. But let's go ahead and guess and check. All right, so I've given you a little bit of a clue that this is definitely a solution. But let's plug it in. I have 2 times my parenthesis plus 9 equals 14, and I'm still not sure whether that's true, but I'm going to test to see if 2.5 makes it true. So 2 times 2.5 equals 5, plus 9 equals 14. 5 plus 9 is 14 equals 14. That's a true statement, and so I know that 2.5 is a solution to the equation. So 2.5 is a solution to the equation. So what that means is, in a nutshell, if we can find the number or numbers, if there's more than one variable, if we can find the number or numbers that plug into the variable positions and end up making a true statement, we know we found the solution. We may or may not have found all the solutions, but we know that that is a solution. So let's look at one more example with an inequality. So we want the variable equation 5x plus 3y equals 27. And at this point we can't solve for the solution here. In fact, when there's more than one variable, there's more than one solution most of the time. But we can test to see if something is a solution, if there is a solution out there that we can validate or verify. So I'm going to try x equals 2 and y equals 5. All right, so if I plug in for my x and y, I get 5 times big gaping hole plus 3 times big gaping hole equals 27. And the big gaping hole just keeps you from making a mistake. If you have lots of negative signs, it's easy to make a mistake. So now, instead of an x, I want to plug in the equivalent value of 2. And instead of y, I'm going to plug in the equivalent value of 5. And I'm not sure if this is a solution, so I'm going to put a question mark. So 5 times 2 is 10, plus 3 times 5 is 15. Does that equal 27? I can already sort of see it does not. 25 does not equal 27. So I can say that these are not a solution. So let's try one more real quick. Let's try x equals 3 and y equals 4. So 5 times, I'm going to plug in there, plus 3 times, I'm going to plug in here, equals 4. And I want to plug in a 3 for x, right? So my first 5 times x, I want to plug in a 3, and I want to plug in a 4 for y. So 5 times 3 is 15, plus 3 times 4 is 12. Oh, I wrote the wrong number here. Does that equal 27? Right, that's the original. 5 plus 12, does that equal 27? So, excuse me, 15 plus 12, does that equal 27? Well, 15 plus 12 is 27, so the answer is yes. We can say definitively now that 3 and 4, x equals 3, and y equals 4, are solutions, or better said, because we're not sure of all of them yet, are a solution to the equation. That's just shorthand for equation. 5x plus 3y equals 27.